who joined us, who is watching live now, and who is watching the report afterwards. So let me start sharing my screen so you can follow what I'm talking about related to Istio. By the way, some people always ask me, what about the slides? Can I have the access to the slides? Yes, you can. If you go to this bit.ly link, bit.ly/istio-kubernetes, you can have access to the slides right now. It's published on Google Slides, so it's continuously being updated. I just updated it this morning before we start the meetup, so just keep this link and you are good to go. My name is Rafael Benevides. I work as Director of Developer Experience at Red Hat. I've been working there. This year, I will complete 10 years of Red Hat. Essentially, I'm a Java developer, but I'm focusing a lot on everything related to containers. Docker, Kubernetes, Knative, Istio. And before we start talking specifically about Istio, I'd like to invite everyone here to join the Red Hat Developers Program, which the address is developers.redhat.com. What you can get there, you will get free resources for developers, like, for example, Microservices for Java developers. By the way, I'm releasing the second edition this year. Building reactive microservices in Java. You have the direct link to these books here. Migrating microservice database, introducing Istio Service Mesh for microservices. So it's everything there for free. You just need to sign up at the website. Okay, let's start talking about Istio. When you propose yourself to create cloud-native applications, you need to go through a kind of evolutionary process, right? So the first step in this process is to reorganize your team to use and adopt DevOps practices. Then you can start having self-service on-demand elastic infrastructure. So usually you achieve that using a cloud or a cloud provider. Of course, you can have a public cloud or a private cloud, but usually cloud is the answer. Then you start having automation with tools like Ansible, Chef, Puppet. Then once that you have automation, you have DevOps practices, you have a elastic infrastructure, the next step would be having a continuous integration and continuous deployment pipeline. And then with a continuous integration and continuous deployment pipeline, you have advanced deployment techniques. And finally, you will have the microservice. Maybe you can become the next Silicon Valley unicorn, right? So if you think about it, everything that you see here, self-service on-demand, elastic infrastructure, automation, CI/CD, deployment pipeline, advanced deploy techniques, you can achieve with Kubernetes, OpenShift, and Istio. So these three have a lot of unicorn love. Okay, but everything started with our majestic monolith, right? We had our monolith for many years. Of course, this monolith inside of it was composed by modules, and there was a moment in time that we divided it in small services, in microservices. Of course, these microservices don't live together in a server. They are spread on a network of services that creates a service mesh, right? And we cannot forget that every microservice owns their own data. So if we have 100 microservices, we will probably have 100 databases. Each microservice can have also multiple points of entry. And when we spread those microservices in a network, we tend to forget about, we are talking about distributed computing, right? But we forget about that. So it's normal to forget and tend to think that the network is always reliable. That's a lie. The network is not always reliable. For example, I'm talking with you all at this moment, but you can face a problem, you can get offline, and you lose this presentation. I can get offline and I can lose my capacity to present this content. We tend to think also that the latency is zero. We tend to think that the latency is zero. We always think that we are connected like local host, no latency at all. We tend to think that the bandwidth is infinite, that the topology doesn't change. There is one administrator that we always forget also about the cost. We tend to think that the cost is zero. The network is homogeneous. All of these fallacies are listed from here, the fallacies of distributed computing. So when a microservice fails, what we don't want is having a cascading failure, right? We don't want that a single failure in this mesh of service creates a failure that will spread to other microservices. So we have some techniques to mitigate those failures. For example, if we have service A calling service B or that calls service C, we need to implement certain features like service discovery, load balancer, resilience to avoid those failures, metrics, tracing, and that is true for service A. Then you need to implement that again on service B. Then you need to implement that again on service C. Let's see how was the history of microservices before we go in deep in this subject. We can see that the cloud was born in 2006, right? Then for those who are Java developers, we saw the dawn of fat jars. Then Netflix OSS, which was the for many years the reference of microservices. Netflix OSS went open source, so we can see the Ribbon, Hystrix, and Eureka libraries here on March and July of 2012. Then we saw in 2014 the perfect storm for microservices. So we had in the Java land we had Spring Boot, we had Docker, we have microservice defined, we had Kubernetes. And that was the perfect moment to start producing microservices. Let's recap all the microservice principles. The first one is the only reason that we decide to implement microservice is to achieve independence, right? Microservice is hard to implement. It's hard to deploy, it's hard to maintain, to manage. So the only reason is because you want to be independent, you want to deploy independent pieces of your software. And you want in the middle of a day, in the middle of, suppose on a Thursday noon, you want to replace the service B by another version, no matter if you have A calling B and B calling C. Of course, you are focused. One of the reasons to have different parts is because you are focusing on the business capabilities. It's not about technology, it's about business. Each microservice is a product, which means that there are clients. You need to provide post-sale, like for example, you delivered a product. You need to know, in a case of failure, who will be called in the middle of the night if something goes wrong, right? Of course, to achieve deployment independency, you need to focus a lot of API, like here on the fourth. And of course, APIs can change. So when we are talking about APIs, we are also talking about evolutionary design. For example, Kubernetes. When in the Kubernetes YAML file, we have the version 1 explicit there. So we know that that format is for version 1. If Kubernetes releases the version 2.0, then we will know the format of the file. So probably if Kubernetes receives a version 1, it will translate internally to version 2. So this is Kubernetes is the perfect example of evolutionary design. I've talked about the decentralized data management, where I said every microservice has their own data. Decentralized governance, each team will manage their own microservice, and so on. Design for failure, infrastructure automation. So these are the microservices principles. We can't forget that. Okay, let's return about the Netflix OSS. What is wrong with Netflix OSS? Usually when I'm speaking in a container group, on a container meetup just like this, we see developers from different languages. We see developers that use Java, developers that use Go, Python, PHP, even .NET. So when we decide to use Netflix OSS, we are talking only to Java developers. And that's a problem. Because no matter what language you choose to implement the microservice, a microservice specifically, you need to provide those capabilities, those properties. For example, you need to provide the API. That's easy. In any language, you will provide the API. Then you need a way to discover that service. That service is on is inside the cluster. So how I will discover it? Then I need to handle the invocation. Is it a HTTP REST using REST? Is it a messaging using AMQ protocol, for example? We need to handle the elasticity. So if one service gets more accessed, it needs more container replicas. How can I scale? The resilience. What we will do if something goes wrong? If service B is offline and service E is trying to reach, what we will do with service B? The pipeline. How will we get that code that's running on that is in your laptop, and we want to release it in production? So what is the pipeline? Authentication. How we will handle the authentication? How we will handle the logging? We are talking about containers that could have many replicas. How we will aggregate that logging? How we will monitor those microservices? How we will perform tracing? And fortunately, we have Kubernetes plus OpenShift. Because with Kubernetes, we have discovery for free, right? We get service discovery with Kubernetes services. We have invocation with Egress, with services. We have elasticity with the replication controller / deployment, replica sets. On the other hand, with OpenShift, we have pipelines, we have logging, and we have monitoring. And finally, with Istio, which is an implementation of Service Mesh. And by the way, what is Service Mesh? Service Mesh is when you have a topology of services that will handle the traffic between one service to another. Usually it's implemented with network proxies, so deployed together with your code. This is the case of Istio. That's why Istio is an implementation of Service Mesh. So with
Rafael,
Istio, again, discovery, a smart discovery, because it handles the traffic in a smarter way. We will see that in a demo that I will show to you. We gain resilience because Istio can provide retry policies, circuit breakers, pull ejections. Istio also provide authentication between
Rafael,
source A.
sorry to interrupt you, but I just see in the chat that you're not sharing your screen. We only can see you all the time.
Oh, sorry. I thought I was. By the way, do you want me to start again? So, or recap the slides?
Maybe that would be great. I would say like make a just keep short overview that the people they not open the slides can.
Oh yeah. Okay, so just recapping, those are the things that we can get with OpenShift, Istio, and Kubernetes, self-service on-demand, Elastic infrastructure, automation, CI/CD deployment pipeline, and defensive deployment techniques. There was a moment that we decided to have a network of services coming from a monolith application, right? We covered the fallacies of distributed computing. We want to avoid a cascading failure. Then we saw that for every microservice, we need to implement certain capabilities like service discovery, load balancer, resilience, metrics, and tracing. And we saw that for many years, all those things, discovery, load balancer, resilience, metrics, and tracing, was implemented using Ribbon, Hystrix, and Eureka, because that was the root of microservices. We went through the microservice principles, and then I talked about the microservice capabilities. So I've talked about that for every microservice, no matter what language you are using, you should provide the API, a service discovery to discover that service, a way to invoke that service, elasticity, resilience, because the microservice will fail. It's not that it can fail, it will fail. A pipeline to get the code in production, authentication mechanism, logging, monitoring, and tracing. So fortunately, we can use Kubernetes and OpenShift. Kubernetes provides us for free discovery, invocation, and elasticity. On the other hand, we have OpenShift that provides us with monitoring, logging, and pipeline. And with Istio, that's the implementation of Service Mesh that I have defined. With Istio, we have a smart discovery because Istio provides us with retry policies, pull ejection, circuit breakers. We have authentication, where a service A calling a service B. You can have a mutual TLS authentication. So the service B will only receive requests from service A. If service C tries to call service B, it will not be allowed. Monitoring, you have that also for free. We will see that in a demo. And also tracing, we gain that for free. So before Istio, we had, like I presented earlier, service A calling service B and calling service C. After Istio, all those functionalities that was implemented using libraries like Netflix OSS, we can implement. We can have that in a sidecar container. The sidecar container intercepts all network traffic, just like it's simple. It uses IP tables to route every traffic to the site container. Then again, using IP tables, the site container will communicate finally with your application. Okay. By the way, the implementation of this sidecar container uses Envoy. Envoy, it's a network proxy. Let me go here to their website. Envoy is an open source edge and service proxy designed for cloud native application. It was written using C, so it's very lightweight, it's very performatic, so you cannot blame Istio and say, I implemented Istio and now my application is slow. No, it's very performatic. So, by the way, the term sidecar came from this picture, from where the motorcycles in the past had sidecars. Okay, and what you gain with Istio? First, you not rely on a library just like Netflix OSS. It's code independent. It's polyglot. You gain for free intelligent routing and load balancing. So you can perform smarter Canary releases. You can have better A/B tests because you can send, for example, I want that only people who are inside my network will see the version 2.0 before 2.0 is released. I want to only people in Europe to see the version 3.0, and worldwide will see the version 2.0. That's one example of intelligent routing and load balancing. You can have a fault injection, which is good for a chaos scenario in a microservice. So suppose that you have a microservice and you want to know how it would behave if the microservice takes 10 seconds to reply. You can provide that. You just write Istio rule, and that specific microservice will take 10 seconds to reply. Or what will happen if my microservice starts to fail? Return a 500 error instead of the proper. So instead of making your service fail, you can write a rule that will make your microservice pretend that it's failing. You can have resilience with circuit breakers. You can have observability with metrics and tracing for free. And of course, this all can be managed in a fleet-wide policy enforcement. How Istio works? So we know that every microservice has Envoy sidecar container running. And in parallel, you have deployed a control plane. The control plane is composed by the Istio pilot, the Istio mixer, and the Istio citadel. The pilot is responsible to send the configuration and keep it synchronized among every sidecar containers, right? On the other hand, the mixer will receive information from every sidecar, and that information is used for a telemetry, for quota, suppose that you want, or for rate limiting, for an access control list. Rate limiting is really interesting because you can say, I want only 10 requests per second in my microservice. One request per second in my microservice. If you receive 20 requests per second, the proxy will deny that invocation. So that's really good. By the way, this sidecar container, the Envoy, works on a higher level, in a higher layer, on the application layer of HTTP. So it understands HTTP 1, 1.1, HTTP 2, gRPC, and TCP with TLS. By the way, regarding to TLS, you have the Citadel, which provides you with a certificate authority, so you can authenticate and create a cipher information between the microservice B and C. So that's how Istio works. But so you can see that with Istio, you don't need Netflix Ribbon, you don't need Netflix Eureka, you don't need Spring Config Server, you don't need Hystrix, you don't need Zoo. You don't need to implement open tracing on each microservice. You gain Jagger for free with Istio. So this is the polyglot platform for 2019. You just need Kubernetes, OpenShift, and Istio. And no matter what language you are using, you can have all those capacities and capabilities. So let's see our first example regarding to observability. Here inside I'm running locally some microservices. You can see here. My microservice A is called customer. My microservice B is called preference. And my microservice C, I have the version 1 of it, it's called recommendation. Every time that I access this microservice, it returns the name of the container plus a counter. And they are running inside OpenShift. So let me open my OpenShift console. I'm running locally using Minishift, which is just like Minikube, but it brings Minishift, okay? So let's see here. Inside the Istio installation, Istio installation gave me, for example, Grafana. So let me open here Grafana. If I go to the Istio workload dashboards, it might be out of date. So yeah, because I restarted my container. So my Istio dashboard, my Grafana is not working. So never mind. But let's see other sources of observability. You just know it's not working at this moment, but you know that it comes from free with Istio. What else do you have? You can have a project called Kiali. Kiali is from Red Hat. I heard that it will become part of Istio. And you can see here in my tutorial, the 3 microservices that I've deployed. So you can see that it's healthy. You can probably create a traffic routing rule from here, but we will not do that. We will learn Istio from the scratch, okay? You can just see how are my graphic of microservices here. The 3 of them, customer preference and recommendation. I want to display the traffic animation so you can see that I'm sending traffic to customer, the customer is sending to preference, the recommendation, and all of them are sending traffic to Jagger collector. Jagger is responsible to collect information about distributed tracing. So if I open here distributed tracing that's also installed as part of Istio, I will see my dependencies. So I can see a graphic here of microservice. You can see that all of them reports to Istio Mixer, just like I said here. They're replying to Mixer. And of course, I can come here to Jagger and see every invocation that was made in this microservice. So you can see that earlier I've tried my microservice. Now I started to place more traffic. I can see details of my code. So here you can see that it's a Java Web Servlet. And I can even track what happened inside the proxy. The component here is the proxy itself. So we have a very detailed tracing inside Jagger. So let me close here Jagger, and let's continue our journey on Istio. So we saw that Istio comes with Grafana. Kiali is a project that you can get it at kiali.io. Kiali.io. It's a service mesh observability for Istio. It's a project from Red Hat. And we have also Jagger, okay? So how does it work? When we install Istio, we get a series of custom resources definition, CRDs, inside Kubernetes. So let me get here and run kubectl get CRDs grep Istio. Let me increase here. So you can see that I have a lot of custom resources definition. But what we will mostly use are these two here, the virtual service and the destination rule. I will talk more about them when we start creating some rules inside Istio. Of course, you have service entry for egress, gateway for ingress. So inside Istio, you have both concepts, the egress and the ingress, policy, service role binding. Okay, now let's recap how we will we deploy an application in OpenShift. What I have here inside my application, inside my demo, you can see here that I have recommendation v1, right? I will release recommendation v2. So this demo here has a lot of different languages. So suppose that you are a Node developer, you have an implementation use Node. If you are a Java developer, you have different implementations using Vertex, Spring Boot, Microprofile. So let's get Vertex, because Vertex is really lightweight. So let me create a package. Once that we have a package, I will use this Docker file here. Was just logging in. I will use this Docker file to create an image. So let's do a Docker build using the tag example / recommendation v2. Okay. Docker image grep recommendation. So I have v1 and v2. So let me deploy v2. So to deploy, I have, oh, by the way, I forgot to modify my source code to v2, right? So it's here. Let me say recommendation v2. Let's package again. Create the image again. Okay, Docker build. Okay, and now what I could do is use this file here, the deployment v2 YAML, which is very familiar to us, to deploy the image that I created, the recommendation v2, right? But that would deploy my application without the sidecar container, right? So what I need to do is use the istioctl command. If I use istioctl command, I can use the kube inject and inform the file that I want to inject my container. So I will use that one, deployment v2. That will create an output with the proxy. Okay, so let me show that redirecting to deploy v2 with Istio YAML. Okay, now, and let me show you the difference between those files. Kubernetes, deployment v2, and deploy with Istio. If we see the merge here, we can see that the kube inject modified the annotations and also created a definition of a container called Istio proxy. That is the proxy of Istio, and of course it mounts a path for the certificates of Citadel. It can mount a path for the proxy configuration. You can see here some ports that opens and binds. And this proxy needs container here is the one that runs the IP table rules. That's why it needs a net admin capability. Okay, so let's use that file to deploy our v2. Let me show the web console here, the tutorial project. I just have recommendation v1, and once that I do kubectl apply-f, this file, you will see here that we'll create, oh, by the way, let me go to the proper namespace. Yeah. Now in the proper namespace, I created recommendation v2. Once that it's ready, we will see it here receiving also requests, not only v1 and v2. So let's wait a couple of minutes. Yeah, now we can see v1 and v2, v1 and v2. Now we can start playing with Istio. Now that we saw how to deploy an application and inject a sidecar container, we will see the traffic control performing a blue-green deployment. So what is a blue-green deployment? It's when your source code arrives on production and we place it on an environment called green, and we change the route to that green version. If something goes wrong, you can change the version to the previous one. At this moment, we saw that we have v1 and v2 deployed. So what I will do here is use some scripts that I've previously defined which make things easier. So let me. For example, to perform a blueprint, if I want to send the traffic to v2, I need two files. I need a destination rule and a virtual service. Let me show these files to you so you can have an idea how the YAML of an Istio file looks like. So the destination rule just gives the name. So for example, it takes a subset based on the label. So every recommendation that has the label v1, we will call it version v1. Every recommendation that has the label v2, we call it version v2. Then the virtual service, here, we can control the weight for that rule. So we will send every traffic, 100% of the track to this subset v2 with which we define it in the in this other file here. Okay, so let me just run that script. Blue-green deployment recommendation v2. Note here that when I place enter, I will see only v2 here, right? But suppose that v2 has something wrong. I can send the traffic back to v1 just using Istio. Note here that I didn't make anything else. I didn't do anything else besides applying rules to my traffic, right? Of course, if I remove every configuration, if I remove the destination rule, if I remove the virtual service, then I have the natural way of Kubernetes, which is a round robin between every service. We can even see that if we look at Kiali. Because Kiali is for observability, we can see that the traffic is sent to v1 and v2, okay? What else we can do with Istio? We can have a Canary deployment. So Canary, I like the history about the Canary deployment because the name Canary deployment came from the British coal miners. They use it to carry a canary with them because if there was a gas leakage, the canary would faint. Hopefully, we expect that the canary wouldn't die, but just in case, they had a canary resuscitator. That was someone told me about that in a presentation where they just closed the door, open the oxygen, the canary would live again. But how that applies to software? The software is the same thing. You place just a small portion of the new version on production, and then we start to increase the amount of traffic that will land in that new version until that we feel totally comfortable and make the canary occupy all the traffic, okay? With Kubernetes, it's always 50-50. So we can see here that when we released v2, we have 50% of the traffic going to v1 and v2. But with Kubernetes, with Istio, we can control. I want 9% of the traffic going to v1 and 10% going to v2, and so on. What we will do now is applying those rules. 9%, 9 to 10, 75, 25, and then do a smarter using user agents. So let's go here and implement a Canary deployment with 90% and 10%. So you can see here that v1 will receive 90% of the traffic. And we see v2 very, very few times. Now if I increase to 75, 25, I will note that v2 will become more frequent. Let's wait. Yeah, v2 again, v2 again. Now almost 3-to-1 v2. v2 again, v2 again. Okay, now let me show you something that's really nice. There is a virtual service that's based on for example, if my the user agent in my header, the header of the HTTP, there is a user agent using the regex string Safari, send the traffic to v2. Everything else go to v1. So let me implement that rule. Let me call Canary with user agents. Now you see that only v1 receives the traffic because I'm using the curl command here. I'm not using the browser. But if I go in the browser, if I go to the browser and open the route here, I will see only v2 because that's what the rules say. No matter if here I receive v1 and here I see v2 because that was specified on the Istio file. Okay, so that's really, 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 really interesting. That's an example of how I can perform smart Canary releases. And once that I remove the rules, we have back 1 and 2, 1 and 2, and here also v1, v2. Okay. What else we can do to Istio? We can perform a dark launch. The great example of dark launch was Facebook Messenger. Facebook Messenger was placed online 1 year before we saw it. And how does it work? The traffic is sent to v1, and v2 will also receive a request, but that the answer, we will never see it. That way we can test how v2 is behaving without the user seeing it. So let's implement a dark launch here. By the way, a dark launch is nothing more than a mirror. Let me look. The destination will go everything to v1, and we will mirror the request to v2. Okay, so let's perform that. Dark launch. Now I can see that only v1 is receiving the request, but if we go to the OpenShift console and open the logs here, we will see that v2 is also receiving the request. So we have the request from, we only see the reply from v1, but if we saw the logs of v2, v2 is also receiving the traffic. What else we can do with Istio? Related to service resilience, remember that I told you about avoiding a failure to be propagated. What I will do now is modify v2 to start failing. Remember that I said, what that happens with if a microservice fails? So let me just modify my microservice to fail, right? Now, oops, I'll see project tutorial. Okay, now my microservice v2 will start to give me an error. You can see here, v2 is failing. 403, if you're, I just have an answer from v2, right? By the way, I also scaled. I have 2 replicas of v2, okay? And one is failing. So v1, v2, and fail. v1, v2, and fail. v1, v2, and fail. What I will do now is implement a retry rule. I want that preference recommendation. If it fails, retry again. So let me implement a rule that will retry the connection. Now you can see that if v2 is failing, it just tries another, it retries again, and finally it gets on a pod that's healthy, okay? Another thing that we can do is provide a pull ejection. Pull ejection, it's different from retry because it, once that it gets the error, it avoids, and then it starts to ignore that for 10 seconds, for example. So you can see that it accessed, it's given an error, so it avoids that for a certain amount of time. Then later, it will that failing pod will become part again of my pool, and then I can see Istio ignoring it again. So it will keep that way forever. So you can, so if you mix, for example, if you mix a pull ejection, a retry policy, and also a circuit breaker that I will not show to you at this moment, you can see that you have the perfect service resilience. You never reach a pod that's failing. Okay. Chaos testing. As I said, what happens if my microservice starts to fail? So let's implement a rule here that I will have the error 503 50% of the time. So 50% of the time, I'm having an error. That was not an error inside my microservice. That's an error caused by the proxy, just for test purpose. Okay? Or what happens if my microservice is slow? So what I can do here is make it have a delay. Now you see that V2 will have 10 seconds to reply. V1 is okay, but V2 always takes 10 seconds. V2, V1 is okay. V2 is slow. That's the kind of thing that we can inject. And to conclude, we can also have access control. For example, A can call B that can call C, but C cannot call B that cannot call C, that cannot call A. That's also possible to do. You have also the egress configuration, because most communication are inbound and internal. But suppose that someone place a malicious code inside your microservice that sends data to outside. Only certain microservices that you define can access the outside world. Everything else is blocked by default. Okay, so that increases the security. Because our time is over, if you want to learn more about Service Mesh, you have at least 3 ways. You can download the book, Service Mesh for Microservices. You can just click in this link or take a note about this link. You will have the book for free, as I mentioned before, the Red Hat Developers Program. Or you can go to learn.openshift.com/servicemesh. This is really interesting. Let me show it to you, because you don't need to install Istio on your machine. When you start a scenario, for example, you will have a web terminal. You have OpenShift, a cluster just for you, everything online. So you can try with admin access, by the way. So, and here you have a web terminal that you can run commands here, and then you see how to install the microservices and learn the simple routing rules, advancing route rules, fault injection, circuit breaker, egress, and Kiali, and also mutual TLS. So it's very, very complete. Or if you want to install Istio on your machine, you can go to this link. That is the code that I used to demo. Okay, here you have the customer, the recommendation, preference. As I said, you have different implementations. You have .NET, Java, Node implementation. And then you have an HTML version where we go through set up Minishift, deploy the microservice, and then do everything that we did. The traffic control, service resilience, chaos testing, the policy enforcement, security, and also even advanced tutorial like differential, zero downtime migration with database, service virtualization. So it's very, very complete. I can say with all my confidence that this is the best Istio tutorial that you ever see. One of the most complete that you should find at the internet. Because if you take a look, we are all working at this project for many months, and it's very, very complete about Istio. Okay, this is the end of the presentation, but don't forget, serverless is coming. Probably you should see one talk related to Knative in the very next days or months. If you want to keep in contact with me after, of course, I will open a moment for question and answers, but you can reach me in this Twitter handle, @RafaBenny. And thank you so much. And finally, I can stop sharing my screen.
Thanks, Rafael. It was really, really great. I just told the people they can also add some questions to the chat. Maybe you would like to have a look in the chat for a few moments. I think there are only 2 questions. The first, I can reply to it. The slides you will probably share, right?
Yeah.
And the video, I will share it on the Meetup group in the Meetup from Rafael, and I will also share it on our YouTube channel. And I think the other question you have to answer because I don't have any idea.
Okay, so let's go through the questions here now. You posted the slides. Okay. And now the problem related to sharing the screen. That was funny.
It's 16 hours.
Okay. You mean 1 request per second in milliseconds? You mean for all pods of particular servers or per single pod? Istio works by services. So if you, let me open here is Chiali again.
It's still a recording, so it's still fine.
Okay. Anyway, let me share my screen, the whole desktop. By the way, because I placed recommendation to fail, you can see it in Chiali. So Chiali works, Istio works by subsets, right? So you can, it's not by service, that's not the proper name. It's by subsets. When you create a subset, like I created a subset for V1 and for V2, you can define rate limit on that specific, let me open here, on that specific subset. So for example, let's take a look here on the rate limit rule. The rate limit rule is a little bit more complex. This is the rule, and this is the handler. So here I can have the 1 request in 1 second. So I define the amount and the time frame. The default is 5,000 requests per second. So I overwrite the recommendation I can overwrite recommendation V2 coming from preference, or I can say source from anywhere, of 1 request per second. Okay? And if you have further questions, please feel free to continue asking. If anybody has questions, can add. I lost first half hour. Publish the recording. Yes. Can you use Istio and Envoy sidecars to handle traffic for Kafka? Oh, that's a very common question. Yes, because it handles any TCP connection, so it's perfectly fine. Although you are not using HTTP or gRPC, it handles very well TCP traffics. Thank you so much. Okay, I understood that protocols like HTTP, gRPC, TCP are supported by Istio. If TCP is supported, does that mean that the layer 7 protocols are supported? If they are based on TCP, like Kafka protocol, those have the protocols are supported. Not every layer 7 protocols are supported. So it's TCP plus HTTP, gRPC, and HTTP 1 and 2. So it's not Kafka protocol. Okay?
Looks like that's it, right? Okay. Great, then I will stop the screen, the recording.